Okay, so find the zeros, axis, symmetry, and graph, any quadratic function. You start with the quadratic formula. Tells you everything you need to know. Now, there's an alternative. You could factor this and find the zeros. Now, I think everybody knew to find the zeros. Okay, of course, I told you that. So, you know, if I just ask, construct the graph of this thing, you're going to have to know. You find the zeros and the axis is symmetry. That's how you start. Well, zeros. It's a quadratic formula. You get x equals negative b plus or minus square root of b squared minus 4ac, all that over 2a. Okay. And we've been over the quadratic formula. If you don't remember it, review the videos, check them, open math video, everything else. But that's going to be, b is what's in front of x. That's going to be 5. So it's negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6. Because a is what's in front of x squared, that's implicitly 1. And c is, remember, it doesn't have an x on it. Get negative 5 plus or minus the square root of 1 over 2. You get negative 2, negative 3. So right away, you have 2 points you can put on the graph. You can also find the y-intercept. That occurs when y equals 6. Because again, the y-intercept occurs when x equals 0. If you haven't picked that up by now, after it's been repeated a dozen times or more, make sure you have it now. Okay. Y-intercept occurs when x equals 0. The x-intercept occurs when y equals 0. Okay, so we're going to have 6 up there. So I'll just put 6 up here. Now you know the graph is going to be a parabola because it's quadratic. You also know that this graph can be constructed by transforming the basic squaring function. So it's going to have the shape of the basic squaring function, might be stretched. It is going to be shifted left or right. It is going to be shifted up or down. So you can, at this point, kind of sketch a parabola. Okay. But to totally analyze this thing, you have to know what the coordinates of this point are here. This is the vertex. I'll emphasize that point. So what do you think the axis of symmetry is? Can you sketch the axis of symmetry? Okay. So for axis of symmetry, Here, your vertex is on the axis of symmetry. Vertex is on the axis of symmetry. The axis of symmetry goes right through the vertex. And what's the equation of the axis of symmetry? You can tell what it has to be because it's halfway between the two zeros. You wouldn't have symmetry if the axis of symmetry wasn't halfway between your zeros. And halfway between your zeros is -2.5. So that's -2.5, which is also -5/2. Okay. So if you have two zeros, you can always figure out the axis of symmetry. And you don't really need to do anything else, but you should, because you don't always have two zeros. What if this parabola was a little bit higher? It wouldn't have any zeros, would it? But what if it's upside down with the vertex there? That we go through the x-axis, would it? Okay. So you have to know what I emphasized last time. The axis of symmetry. It's easy to find because it's halfway between the zeros. Also easy to find. Just -b/2a. You have a plus or minus here, plus or minus 1, -5, plus or minus 1. What's halfway between -5 plus 1 and -5 minus 1? -5. That's what's halfway between -5 plus 1 and -5 minus 1. Just like what's halfway between 1 foot to the right of my nose and 1 foot to the left of my nose. My nose. Okay. So there's a symmetry. It's built in right here. And that gives you -5/3 also. Now, if you got a parabola that doesn't go through the x-axis, like if I had a +8 here, that would make all your y coordinates 2 greater, right? It would raise every point of the graph 2 units and it wouldn't go through the x-axis anymore. It would still have an axis of symmetry that you can find hiding right there in plain sight in the quadratic formula. Not a separate formula you've got to remember, but you do have to remember the quadratic formula. That's irreducible. You've got to know that. You're not going to have a formula sheet in the test. Okay. All right. I mean, you're going to have to remember like y equals mx plus b in the quadratic formula. Okay. It's pretty much the only formulas you really have. I mean, there's a formula for slope, but we use fundamental triangles. And everybody uses that formula anyhow, so you like to remember it. So I don't even acknowledge that formula. Okay, well, there we have. Once you have the axis of symmetry, you can find the vertex. Because you know, yeah, the vertex occurs when x is -5/2. Okay, well, how do you figure out y if x equals -5/2? You plug in -5/2 for x. Okay. Now we did this last time we went through the class. Do the notes. Have to know this. I guarantee you, you're gonna have to do this on the midterm test, which is coming up. I don't think that's good. That's also kind of a alert. We really thought of you reviewing everything we've done, starting right away. Okay. So the vertex. And if you figure that out, it comes up -140. There it is. -5 has -140. And again, you can find the vertex whether you have zeros or not. Graph could be all the way above the x-axis, could be all the way below the x-axis, doesn't have to go through the x-axis. Does have to go through the y-axis, so you've always got the y-coordinate. Okay. Now, not only are you going to need to be able to do that, but I also guarantee I'm going to ask you to list the transformations you would use to transform the squaring function, the basic squaring function, to get this function. Transformations. Have a vertical stretch. Vertical shift and a horizontal shift. The vertical stretch doesn't affect the origin. You apply a vertical stretch to the basic toolkit squaring function. You have the 0.00, that's your vertex. No matter how you stretch function where y equals 0, a point where y equals 0, it doesn't go anywhere. Okay. So the vertical stretch, well, it turns out the vertical stretch is 1 because you're going to have x squared. That's because a equals 1, a being the number in front of x squared. Whatever's in front of x squared, that's your vertical stretch. Vertical stretch factor 1 doesn't move anything. You multiply every y coordinate by 1. Starting with the basic squaring function, so you don't mess with it. In this case, vertical shift. Well, what do you have to do? What vertical shift takes the vertex of your basic squaring function to the point, -5/2, -1/4. Don't say anything, you're recording, okay? Can you write that down? Should be able to write that down in an instant. Okay. To get from 0, 0 to -5/2, -1/4, you have to go up or down, just point up or down. Gotta go down. You're going from here to here, you go down. How far do you go down? Quarter of a unit, 1/4. That's what the -1/4 means here. Okay, so the vertical shift is -1/4. Now your vertex has to go from here to here. So far, you've got it going from here down to here, right? Okay, so let's draw a picture of what we've got. So you got your basic square function. How badly drawn. Figure 2 square, badly drawn, but the vertex is supposed to be here. No vertical stretch, variable stretch is 1. These are no stretch. Vertical shift, -1/4. So here's our vertex. Our vertex is 0, -1/4. We do a vertical shift to -1/4, which is what we said we do. The horizontal shift has to be -5/2. Now we're off the screen here, but we know that we're going to go to -5/2 because the vertex is going to be at -5/2. So we can even sketch our vertex here. So let's see, this would be like -1, -2, -3. Our vertex is that -5/2, 1/4. Okay, so we take this whole graph and we shift it down a quarter, being so the vertex goes to here. Then how are we going to get the vertex there? We've got to move it to the left 5/2 of a unit. That's why the vertical horizontal shift is -5/2. Now we got the vertex here. We haven't stretched the graph any. The graph is going to look just like this, except it's going to then move down a unit and over 5/2 of a unit. Now, the equation in vertex form is y equals a f of x minus h quantity plus k where f of x is a basic squaring function. A equals 1, h equals -5/2, k equals -1/4, because as we need to know by this point, and as we have done for weeks, h is the horizontal shift, a is the vertical shift, a is the vertical stretch. F of x is x squared. So if f of x is x squared, f of x minus h is x minus h squared. H is -5/2, so we have x minus -5/2 squared. So that's f of x minus h. A f of x minus h is 1 times x plus 5/2 quantity squared. Now, I'm taking the liberty of saying that x minus -5/2 is x plus 5/2. And here's, of course, the 1 doesn't matter, so we just write that as x plus 5/2 squared. So that a f of x minus h plus k is x plus 5/2 squared plus -1/4. So we get y equals x plus 5/2 quantity squared minus 1/4. That's the vertex form. So from this, we found that the vertex form of y equals x squared plus 5x plus 6 is y equals x plus 5/2 squared minus 1/4. So I want you to verify that. I want you to expand this square here, do the arithmetic, and see if this isn't equal to this. So we expand this to verify that it really does equal this. use the distributive law, expand that square. Okay, now 60% of the class told me that x plus 5/2 squared was x squared plus 5/2 squared. How many times have I repeated? Exponents don't distribute over addition. Multiplication distributes over addition, okay? And we really got to get this straight. I mean, we have to be beyond basic algebra 1, okay? We really have to be beyond that at this stage because we're having to spend way too much class time fixing these errors. So I'm going to try to get you a set of problems like I did last time. And the ones I handed out before last, I think. Hopefully you've used those. Because you really have to get that algebra down and you have to understand this algebra of the distributive form and what it means to square a binomial. Okay, this is x plus 5/2 times x plus 5/2. And x plus 5/2 times x plus 5/2 is x times x plus 5/2 plus 5/2 times x plus 1,000. Distributive law is not a bunch of loops. Although the loops help you visualize it, I really don't want you writing out loops unless you also write it out like this. If you write it out like this and do it right, and then write it with loops and see how that works. Okay. That's not the way the law is stated. The law is stated this plus this multiplied by this is, okay, x plus 5/2 multiplied by this thing over here is x multiplied by that thing plus 5/2 multiplied by that thing, and you have to know that. And then everybody's okay when they get to this stage. Because, you know, you multiply x by x, x by 5/2, 5/2 by x, and 5/2 by 5/2. That is the distributive law. People are having trouble applying it, but it looks like this. Have to get past that. Okay, so that's x squared. 5/2 x and 5/2 x. Double 5x. 5/2 and 5/2 is 5. That's basic fractions. And that's 25/4. I think, aren't going to get this unless you write it out in this form. Okay. We've done it in class, but it really hasn't taken. Because people still want to tell me this is x squared plus 5x squared. So I'm urging you, write the distributive law like this. So you'll understand and you won't be making that mistake. Okay. Also, I gotta say, check your work. Okay. Check your work. You're gonna find if you expand it, doing what you did, it's not going to equal this, it has to equal this. Okay. So if you go through this whole process and then check your work by verifying, check your work by expanding this and see if it does really give you this. It's not gonna. And then you're not going to go where you went wrong, and you're not going to understand where you went wrong in the whole process. Okay, you know you made a mistake somewhere. Where are you going to find your mistake? There's a lot of steps to this process. And if you've done everything right in the whole process and done this one thing wrong, it's going to confuse the heck out. Okay. And you're not going to learn the process very well because you're not going to really believe it. Okay. So if we expand to verify, so I'll write this down kind of small, but it's this expands to give you x squared plus 5x plus 25/4. And then you still got your minus 1/4. But what's that equal? Well, 25/4 minus 1/4 is 24/4. That's x squared plus 5x plus 6. And that does match. Okay. Almost everybody's really going to need some practice in their algebra. So I'm going to try to give you that practice. You're going to have to use it. You're going to get it. Or, yeah, you can always go to a tutor. I've got a great tutor in the testing center. Right next to the testing center in the mark. There's no substitute for doing a lot of exercises. So I'm going to give you pretty much an unlimited set of exercises. As many solved problems as you might want. And if after you've done the 10,000 problems I send you, you want another 10,000 or 20,000, all I got to do is push the buttons. Well, you're not going to want it. You're not going to do 10,000 problems. You don't take time. But you need to do a sufficient number of problems that these rules get ingrained. And one difficulty, I think, is that it's very difficult to get algebra students to do enough problems to learn the algebra. Okay. Most people simply will not do it. But our schools say everybody's got a pass. People sit in their phones and still pass. And people who do have the desire to learn it are in a class with people who don't. So they don't really have to learn it either. It's and let me emphasize that you are going to have to deal with this. Maybe not next week, maybe it'll be the following, it'll be right before spring break. Midterm test is going to be assigned. Okay. And I'll probably accept it like the 2 days we come back after spring break, but it's going to be due the week before. So if you want to ruin your spring break or need to ruin your spring break by having to do a lot of math, because I'm trying to give you a break, I don't have any assignment with the break. If you need the break, prepare for the midterm, so be it. I hope we get it done before that. Everybody needs a break at that point. And it's nice to be able to just get your head away for a week, do something else, come back fresh, ready to learn the rest of the course. Okay. So most of you appear to need practice. So I'm going to try at my best by Thursday to give you some practice. Okay. Here's a polynomial. Okay. So graphing. I'm just kidding. Okay. But we can start to graph that thing. Because we know that x to the fifth is dominant. that means it's going to look like x to the fifth, which is a lot like x cubed, but it almost flattens out here after the next cube, and then it's all. But the graph's going to look kind of like this. But in here, there'd be wiggles, like the old maps. Old maps back in the 1600s, maps of the world would have an ocean that hadn't been explored and say, here there be monsters. Okay. Well, in that sense, here there be wiggles, but they're not really monsters. Okay. They're not monsters, but they're sort of monsters. Okay. For this function, we can't be guaranteed that this function, that we can factor this function. Okay. So the wiggles found by factoring, but we can't always factor polynomials. So we're not even going to try. At least not with this one. Okay. Now, if the polynomial is simple, like x squared plus 5x plus 6, we can factor that. X plus 2 times x plus 3. 0 is at -2 and -3. Okay. For now, we're going to assume that the polynomial has been factored. The factored polynomials you're going to get in this assignment have already been factored for you. So, try. Y equals x plus 5 times x plus 4 times x plus 1. Well, I can start a graph. I've got a lot of information about the graph right there in that formula. Okay, can you find the x-intercepts? And can you find the y-intercepts? So I'm going to ask you to do that. Find the x-intercepts. Yeah, this is a polynomial. Acts like x to the fifth. Like y with x to the fifth, but okay, double but here in the middle there be with okay, like monsters, here there be monsters. Okay, middle maps. Okay, we find wiggles by factoring. We can't always factor polynomials. Not guaranteed that we can factor this and all that thing. Here's a factored polynomial, x minus 5 times x plus 4 times x plus 4. Find the intercepts. Oh. Zero equals x minus 5 times x plus 4 times x plus 1. So what values of x make that true? It's easy, just set each one equal to 0, get the solution. So the x-intercepts -4, 0, -1, 0, and 5, 0. So So we throw those into the graph. That's a very easy step. If you have a polynomial factor, you can just write every factor, set it equal to 0 and solve. Okay, so if I had a 7x plus 4 plus 38 as one of the factors, I'd have to write 7x plus 38 equals 0 and do the algebra to solve it, but everybody can do that. Okay. So it's not difficult to find zeros if the polynomial is factored. Okay. Now, what about the y-intercept? X equals 0. We get -20. Okay. So I'm going to put -20 here. Simply because I don't have room to put it much lower. That's the y-intercept. That's even easier than the x-intercept. If x equals 0, we just plug in 0 and we get a result very quickly. If y equals 0, well, then we've got to set each factor equal to 0 and find what x is. But there we have it. Okay. The long run behavior. So I can put out a little board space. Okay, the long run. Long run. This is like y equals x cubed. So it has a graph. It looks like the basic cubing function. With wiggles. So we can hit the zeros. Well, where are our zeros? On the scale of this graph, the zeros are like here, here, and here. They're in real close. Okay, so right here is the region where the wiggles are. The wiggles are here. For the cubing function, y goes to negative infinity on this side. Y goes to infinity on this side. Which means that the graph, if I'll do in blue, has to go like this. And like this. Negative infinity here, positive infinity there. If we're going to draw the graph, then we've got to come up from the depths, go through this point, through this point, through this point, through this point, and then go on back up toward infinity. Okay, we're really just drawing an x cubed graph with some modifications to that. So the graph moves up like so. Down like so and up like so. Okay, I guess people kind of agreed. People tend to be agreeable whether they really agree or not. But I think everybody sees that this is a much simpler process than the one we just looked at with quadratic functions, graphing, constructing the graph using transformations. Okay, that's a pretty complex process. You have to know the pieces, and then you got to put them together. Here, the pieces are really pretty simple. I think everybody sees it. And you just if x equals 0, it's real clear what you get for y, so you get the y-intercept. If y is 0, well, you got a little more work to do, but it's real easy to find the x coordinates for the x-intercept. Okay. Then the long run behavior. Now I said this is like y equals x cubed. Why is it like y equals x cubed? Well, if I multiply x plus 4 times x plus 1, I'm going to get an x squared out of that and a lot of other stuff, right? It's going to be x squared plus 5x plus 4. The main thing we want to look at is x squared, right? And then if we multiply by x minus 5, we're going to multiply that x squared by x, also by minus 5. But the point is, we multiply x squared by x, we get x cubed. So we're going to have an x cubed. So x cubed is going to be the leading term, the term of the highest degree. And then the graph is going to behave like the x cubed graph. Okay, there's a little more to it. If you got a number on here, that number might be negative, so the graph would be like a negative x cubed. Well, that means just flip this thing upside down, and negative x cubed is going to come down here and do this. Okay. So, but I want to prove to you, just to make sure you understand that this does give you the x cubed term, so I'm going to expand this. Okay. So I say this is like x cubed, and I'm sure you believe me. You ought to be a little skeptical because sometimes I say things wrong. Okay. But why is this like x cubed? Well, I multiply this out. And I multiply by first multiplying these two terms. Okay. Then I use the distributive. I use a distributive law to do that. I'm not gonna, we've already emphasized that, but I'm gonna use the distributive law here to make sure we understand. Okay, so this is x minus 5 times this r bar here. Okay, x minus 5 times this quadratic expression is x times this minus 5 times this. This is the distributive law. Then multiplying x through here, I get x cubed plus 5x squared plus 4x minus 5x squared minus 25x minus 20. That equals x cubed. Now I happen to have 5x squared and minus 5x squared. So just coincidentally, my x squareds add up to 0. Okay. And then I have 4x negative 25x. That's minus 21x minus 20. So if I did this right, and you might want to check me. I didn't make mistakes. Same as x squared, x cubed minus 21x minus 20. Notice the cube. So there's your leading term. Obliterated by cube. Okay. Well, here's your x cubed. That's why I say x cubed is a leading term. Now things get a little more complicated. Yeah, I think that's what it is. Okay. Okay. Let's contrast this. With what we get if we do y equals x minus 5 times x plus 4 squared times x plus 1. Now, how does this differ? I've got the same factors, x minus 5, x plus 4, and x plus 1, right? Same factors. So the zeros are still same as they were. So I've got zeros at -4, -1, and 5. But one intercept is going to be a little bit different. Because of course, instead of just zero minus 5, 0 plus 4, 0 plus 1, We got a square in that 0 plus 4. And of course, that gives us 16x is -8. Well, my y-intercept was at 0, -8. Okay. Now, if I try to come up from here, down through here, and up through here, it could work. But the problem is, the long run behavior is like x to the 4th. Because x plus 4 squared is going to give me an x squared, right? When I multiply that by x minus 5, it's going to give me an x cubed. And when I multiply by x plus 1, it's going to give me an x to the 4th. And x to the 4th has a graph. It looks like this, a lot like x squared, but flatter at the bottom and steeper on the sides. And x to the 4th goes to plus infinity on this side. It goes to plus infinity on this side. Which means that our graph here has to have the same behavior, but with wiggles. Okay. So, long run behaviors gotta do this. Gotta do this. And this. We've got to go through these points. How are we going to manage that? Well, if we come down from this side and try to go through the axis and then come back up like this, we're not going to get to this point, are we? Okay. So we can't do that. We can't come down here and get this and then loop back. It's a function. We fail the critical line test. Okay. Well, so what we do is we notice that the x plus 4 is squared, which means that this behaves like a horizontally shifted x squared graph. There x equals -4. Okay. So the graph does this. Okay. This is like graph is temporarily parabolic here. Since it's like x plus 4 squared. Since we got an x plus 4 squared. That 0 comes from x plus 4, which is squared, or hashtag of the square. Okay. And that's it. So you got to be aware of that. And of course, if you had an x plus 4 cubed, the graph would act like a cube when it comes to that point. You know those basic functions. And what we talked about last time with the 4th power and 5th power. Then it's not hard to understand why the graphs do what they do. Now there's more to it. Haven't had time to do it all. There'll be a couple of problems near the end where you got to figure out what the formula is for a graph. Give you a graph, ask you what's a polynomial. Okay. It's actually fairly easy. We'll go over it next time if you have trouble. If the open math explanation doesn't make sense. If you understand this much, we got a good start on the whole thing about polynomials. So see if you can nail this one.